All right, hello everybody, and welcome to the Morrison Planetarium. My name is Cheryl, and I have the pleasure of being your pilot today through a tour of the universe. And I'm not just a bodiless voice coming out of the walls, I'm a real person, and I'm right behind you up in the control booth. Hello, welcome, nice to see some faces, glad to have you here. So this show is a little different than the ones we have throughout the day because this show is 100% live. I will fly us away from our home on Earth to explore our solar system, our galaxy, and go out to the visible reaches of the universe. Now, our spacecraft is a software called OpenSpace that was built in partnership with NASA and uses models to create a 3D visual of our universe. It also uses updated information so everything we see is almost in real time out there in space. And finally, the software is also open source, so you can download it for free onto your gaming computers at home and explore the universe at your leisure. Now, before we start this tour, I do have some housekeeping items to review with you all, so I'm going to do that real quick here. So first, I do highly encourage folks to wear a mask in this crowded and indoor space. And in an effort to keep this space clean for you and future guests, we do not allow any eating or drinking in here. If you all have electronics with you today, I suggest setting them to silent and tucking them away for the duration of the show. We would like to avoid any light or sound distractions. Plus, we don't allow any photography or recording during the show. Now, it gets pretty dark in here, so if you're standing or moving around, it can be easy to stumble or even trip. So for your safety, I say stay seated for the whole show. But if anyone needs to leave early, we have exits for you at the top of the planetarium up the stairs on both sides. And finally, thanks to our large dome here, our shows get pretty immersive. So if you start to feel any discomfort, like motion sensitivity or dizziness, I suggest you take a moment to close your eyes, take a few deep breaths, and that should give your brain a chance to remember you're comfortably sitting in a planetarium and not actually hurtling through space. All right, and with that, let's get started on this tour. All right, so we are going to begin our journey a few hundred miles above the Earth here at the International Space Station, or the ISS. Now, this is essentially a large orbiting research station that slowly gets larger as more modules are added to the structure. It is the largest object that we have built in space so far. It's comparable in size to an American football field, and also lengthwise, it's about the size of our Academy building that we are in right now. Now, nations around the world participating in the ISS program send astronauts to live on the ISS, where they will work through experiments to learn how things like water, fire, plants, and even how our human bodies function under the harsh conditions of space. And nowadays, the ISS is the farthest humans travel into space. And at any one time, we can fit 6 astronauts comfortably on the ISS. Now, the ISS orbits the Earth 16 times every single day, so it's moving very fast above us. And you can actually find out when the ISS passes over your area by checking online at spotthestation.nasa.gov. On a clear night sky, it'll look kind of like a bright little star that's moving very quickly across the sky in a pretty straight line. Now, as we get farther and farther away from the ISS and our planet here, we're going to see how far our human influence has spread throughout space, how far humans have physically traveled, how far our spacecrafts have gone, and how far our human communications have gone as well. Now, next, we're going to stop by Earth's moon, the 5th largest moon in the entire solar system, which is pretty impressive since there are over 200 moons total in our solar system. So let's fly in over there right now. Okay. Now we're coming up on a beautiful full moon here. You might have noticed the beautiful moon in the sky the last few nights. Now the moon is Earth's closest natural neighbor. And for millennia, our moon has been important to humans, helping us track time and inspiring myths and legends of different cultures. Now, every 27 days or so, or about a month, the moon completes a full orbit around us. But we only ever see one side of the moon because it revolves around us and rotates on its axis at the very same rate. I'm going to fly in a little bit closer here so that we can see the many, many impact craters on the moon's surface. Now, many of these craters are named after different scientists and astronomers, like Tycho, Marie Curie, and Tereshkova. And it may look like the moon's been hit by asteroids and meteorites more often than us. But Earth is a much bigger target, and we have had our fair share of impacts. But because the moon doesn't have an atmosphere like Earth, nor does it have any wind, water, erosion, or even tectonic plates, there is nothing to erase these craters after they appear on the moon. And most of these craters are very old. One of the more recent craters that was formed over 100 million years ago. So a good chunk of time. Now, the moon is as far as humans have ever traveled out into space. NASA astronauts Buzz Aldrin and Neil Armstrong were the first humans to walk on the moon's surface in 1969. Since then, 10 other NASA astronauts have walked on its surface. Now, currently, NASA is planning a new mission to the moon called Artemis, where they will send the first woman to the moon and lay the foundation for humans to plan missions to Mars. And our moon may be our closest natural neighbor, like I said. It only takes about 3 days to fly up there, but it's still a whopping 250,000 miles away from us. And as we continue on this tour, distances are going to hike up into the millions, billions, and even trillions. And at that point, it doesn't really make sense to use miles or kilometers as a measurement of distance anymore. So instead, we're going to talk about distance using the speed of light. The visible light that we see is part of the electromagnetic spectrum, and it is the fastest thing in our universe that we know of, clocking in at almost 200,000 miles per second. So if NASA astronauts were traveling to the moon in light speed, instead of taking 3 days to fly there, it would only take them about 1.5 seconds. So we say the moon is about 1.5 light seconds away from our planet. Now, light speed is also a measurement of time, but let's talk more about that at our next stop. We're going to fly on over to our very own sun. Now, our sun is 8.5 light minutes away from the Earth. That means when we look at the sun from Earth, we are seeing what it looked like 8.5 minutes in the past, because it took 8.5 minutes for that light to leave the sun, move through space, and reach us on Earth. And our sun here is a middle-aged dwarf star, about 4.5 billion years old. It's mainly composed of hydrogen and helium, and its massive gravity holds our entire solar system together. And just like the Earth, the sun also spins on an axis, but because it's not solid, the sun's made of gas, different sections will spin at different speeds. For example, the sun spins faster at its equator and slower at the two poles. Now, obviously, we don't send humans to the sun, but in 2018, NASA launched the Parker Solar Probe to learn about our sun from up close. And recently, Parker Solar Probe entered the sun's solar atmosphere, closer than any spacecraft has come to our sun, where it was able to sample particles and the magnetic field there. And so spending time learning about our sun can help us better understand Earth and other stars in the universe. Okay, now go ahead and stow away your sunglasses. We're going to head out to the other planets here. So let's pull up their orbits so that we can get a sense of where they are sitting. And first, we're going to start to see our rocky inner planets. We have Mercury, Venus, Earth, of course, and Mars. And then further out, we'll see our gas giants, Jupiter and Saturn. And at the very edges of our solar system, we have our icy giants, Uranus and Neptune. Now, right here, you might have noticed that there's a sizable gap between Mars and Jupiter's orbits. But this isn't just empty space. This is where we find most of the asteroids in our solar system. This is the main asteroid belt. And back in 2015, NASA used a spacecraft called Dawn to explore a particularly unique body within this crowded asteroid belt, a dwarf planet named Ceres. Now, here is that dwarf planet's orbit around our sun. Not a lot of people have heard of Ceres, though, but there is another dwarf planet in our solar system that is very well known. Does anyone know the name of that other dwarf planet? You can shout it out if you know it. Yes, Thank you, Pluto, the dwarf planet out past Neptune. Now, the reason I bring up Ceres and Pluto is because they have pretty similar stories to each other. When we first found Ceres over 300 years ago, we thought it was the only thing orbiting in between Mars and Jupiter. But around that same time, a lot of astronomers are starting to find a lot of small rocky objects that they were calling asteroids. And so Ceres was then changed from a planet to an asteroid. And similarly, when we first found Pluto, we thought it was the only thing orbiting out here. But then in the late 90s and early 2000s, astronomers started to find all these other objects. They found the Kuiper Belt. And so these are mostly small icy objects, but some of which are around the size of Pluto. And at least one is almost as big as Pluto. So instead of adding another dozen or so planets for all of us to memorize in school, astronomers around the world got together and created a better category for these small objects: dwarf planets. And so now there are 3 requirements for anything to be a fully fledged planet in our universe. 1, it needs to orbit a star. 2, it needs to be large enough or massive enough that its own self-gravity can pull it into a round spherical shape. And 3, it needs to have cleared its orbit. Well, Pluto, as we can see, goes right through the Kuiper Belt and doesn't have a clean orbit. So as of 2006, we do not call it a planet anymore. But Pluto does orbit the sun, and it is big enough to be a sphere, so it's a dwarf planet, shifting from the smallest of our planets to now the largest dwarf planet in our solar system. I would call that an upgrade. Now, while we can still see Pluto, let's use its orbit to get a sense of distance. At light speed, to get from one side of Pluto's orbit to the other would take us about 10 hours. So that is 10 light hours across. Now, we know that humans haven't traveled to any of the other planets in our solar system yet. But we have sent robots like rovers, probes, and other unmanned spacecraft to explore for us. And so these orange lines here, they are showing how far our fastest and farthest spacecraft have gone so far. They are all traveling fast enough to escape the sun's gravity and leave the solar system. We have Voyager 1 and 2 and Pioneer 10 and 11, all of which were launched in the 1970s. And most recently, we have the New Horizons spacecraft, which went out to Pluto in 2015. You can see that shortest orange line there that intersects Pluto's orbit. That is the New Horizons spacecraft. And they have all traveled fast, and they have definitely journeyed far. But even still, all these spacecraft have only gone as far as light can travel in a single day. So that should tell us that we have a lot of ways to go to get to the edge of the universe here. So let's keep flying, because I'm going to now fly you out to interstellar space so that I can show you the very farthest that our human technology has reached in the universe. And so now we can start to see the true brightness of our star next to all the other ones we have here. And from here, we can start to see our radiosphere. So this radiosphere, it represents how far radio waves emitted from Earth's radio and TV signals have traveled since we first broadcast them. Now, radio signals that were strong enough to escape our planet were first sent out in the 1930s. So this radiosphere is about 90 light years away from us in all directions. And remember, radio waves travel at the speed of light. So this radiosphere gets 1 light year wider every single year. And while we're out here, I want to show you the other planets that astronomers have identified. So every one of these markers is a star with at least one exoplanet around it. That's a planet that's outside of our solar system. And we have found thousands of weird and interesting exoplanets so far. I mean, just this year, we surpassed finding 5,000 exoplanets. And astronomers use telescopes like the James Webb Space Telescope that was recently launched to explore these exoplanets using infrared technology. Now, if you look a little carefully here, you can see that there are several exoplanets inside our radiosphere. So, If there is life on any of those exoplanets, they would be able to detect our old radio and TV broadcasts, which would be pretty amazing. But we're going to keep flying here because we're still just flying past stars in our galaxy, and we haven't even gone outside of our Milky Way yet. Now, as we zoom out, though, I do want you to keep an eye on the radiosphere and see how long you can keep track of it. Soon we'll start to see that large-scale structure of our galaxy, and we live in a spiral galaxy, so it's pretty flat like a disk, and it has spiral arms of gas and dust and stars. And we're in one of those spiral arms called the Orion arm, about 2/3 out from the center. And right in the very center, you'll see that really bright group of stars that's really densely clustered together there. And if you could see past all those stars, right to the very center of the Milky Way, you would see, well, basically nothing. Because we have a supermassive black hole at the center of our galaxy. It's about 4 million times the mass of our sun, and it's called Sagittarius A star. And if you've been keeping up with the news, you might have noticed that we have just recently taken a photo of Sagittarius A star, which is pretty cool. Now, I'm going to stop flying here and give you a chance to spot our radiosphere before I point it out to you. I think I see it right there. So that tiny, tiny dot right there is the farthest that any of our human communications have gone out into space so far. And now we're up to distances of thousands of light years, because from one side of the disk to the other, our galaxy is about 1,000 light years across. But our galaxy, with its roughly 400 billion stars, is just one galaxy out here in the universe. Every dot that we are seeing now is not a star, but another galaxy with its own billions or sometimes trillions of stars. Now, the closest large galaxy to our Milky Way is the Andromeda Galaxy, 2 million light years away. But don't worry, it's slowly moving closer to us each day, and it'll get here in about 5 billion years or so. But as you see here, galaxies are not evenly spaced out. They tend to cluster. The Milky Way and Andromeda galaxies are grouped with about 40 other galaxies in a cluster called the local group. It's kind of our little local neighborhood. And astronomers use the different colors that we're seeing here to show the different galaxy clusters and help identify them. Now, if we fly out far enough here, we're going to start to see a strange shape that these galaxies seem to form. It's going to look kind of like a bow tie or a butterfly. Now, the universe is not actually shaped like a butterfly, though I think that'd be pretty cool. But it looks like this because we're looking out at the universe from our perspective here on Earth. And so this is actually a map of the galaxies that we can see and have found so far. And since this is from our perspective, it makes a few things look a little bit strange. For one thing, it makes it look like the Milky Way is right at the center of everything here. But as far as we know, there's no center to our universe. If you were to go to any of these other galaxies, it would also look like you're right at the center with everything else moving away from you. And the other strange thing here is that we have this very large gap out here, and this pretty big gap over on this side too. Now we see these strange gaps here because the flat disk of our galaxy, which has a lot of gas, dust, and stars in it, obstructs some of our view of the universe around us. So there are even more galaxies to see and map in those directions, and over time, as we innovate our technology, we will begin to fill in those gaps. And as you can see, we've already kind of started doing that with some of these purple clusters there. Now, if we go a little bit farther, we're going to start to see some of the earliest objects in our universe. They're coming up here on the dome as these kind of reddish orange points of light, and they are quasars, highly luminous cores of some of the first galaxies formed in our universe. Now, one of the largest known quasars is Ponua Aina, a colossal object powered by a supermassive black hole that's 1.5 billion times the mass of our sun. This ancient quasar formed over 13 billion years ago. And when we use our telescopes to view quasars or anything out in space, we're kind of time traveling, because the light from these objects has to travel so far across space that by the time that light travels all that distance and gets to our telescopes, we're seeing the light of these objects as they were in the past and not how they look today. Now, I made the same point earlier about our sun. When we look at our sun, we're seeing what it looked like 8.5 minutes in the past because it takes that long for the light to reach us. And so here, we're seeing the universe as it was about 10 billion years ago. And interestingly, that means we only have a little bit farther to go because there is an edge to everything that we can see in the universe. And that edge is all around us now. So this fuzzy light we see everywhere, that is the cosmic microwave background radiation, or the CMB. This light is the residual radiation from the Big Bang, and it is the earliest light that we can see with our telescopes. With a radio telescope that could see in the microwave range of the electromagnetic light spectrum, you could see this everywhere you look in the sky. In fact, the first radio astronomers were pretty confused by this. They looked up into the sky with their telescopes and thought that they were getting interference everywhere they looked. But soon they realized that this was something out in space that they were seeing. And what we're seeing here is a few 100,000 years after the Big Bang would have happened. So you can think of this as a baby picture of our universe. It is the first light that we can see. But since this is the edge of everything that we can see, that does mean we can't go any farther, and we've reached the end of our journey today. So we're going to start beginning our descent back home to Earth. And if we were actually this far away in space and we were actually flying at the speed of light, getting back home to Earth would take us about 13.7 billion years. But thankfully, we're in a planetarium, so it should just take about a minute. Now, there's one more thing I want to point out as we zoom back home. All of this that we've looked at today, all of these stars and galaxies and the cosmic microwave background, that's not even everything that's in our universe. There is dark energy, a mysterious force that's causing space itself to accelerate as it expands. There's dark matter, a mysterious substance that doesn't seem to interact with light at all, but we see evidence of it in between and at the edge of galaxies especially. And we call these things dark energy and dark matter because we're not quite sure what they are yet, but we do know that they make up about 96% of our universe. So everything that we've seen so far, that's only about 4% of everything that's out there. And sometimes knowing this makes me feel very tiny because we're this one little dot in a humongous universe. But then I remember that even as a small dot, look at all that we have found so far, almost entirely just by looking through telescopes. So there is a whole lot more to discover, and there's a whole lot more to learn about. And that's what makes this such a wonderful time in human history. We're able not just to learn these things, but to share them like this, mapping the cosmos in 3 dimensions. We are finally starting to unravel the true nature of the universe, but we are only starting to unravel it. And the rest, well, that's going to be up to the next generation of scientists back home on Earth. And here we are, approaching that 3rd planet from the sun now. The only place in all of this where we have found life so far. Now that's pretty incredible to think about after everything we have just seen. Our tiny blue and green home is a pretty special place in the universe after all. So I'm going to drop you all off here, and that concludes our journey together today. So I want to thank you so much for joining me on this tour through the universe.